Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to launch your next project, you'll need somewhere to deploy it, so you should check out Linode at dataengineeringpodcast.com/Linode and get a $20 credit to try out their fast and reliable Linux virtual servers for running your data pipelines or trying out the tools you hear about on the show. And go to dataengineeringpodcast.com to subscribe to the show, sign up for the newsletter, read the show notes, and get in touch. You can help support the show by checking out the Patreon page, which is linked from the site. To help other people find the show, you can leave a review on iTunes or Google Play Music, tell your friends and coworkers, and share it on social media. Your host is Tobias Macey, and today I'm interviewing Kamil Bajda-Pawlikowski about Presto and his experiences with supporting it at Starburst Data. So, Kamil, could you start by introducing yourself?
Sure. Hi, Tobias. Pleasure to be here. So I'm a co-founder and CTO of Starburst Data. And Starburst Data is all about Presto, which I will obviously introduce later. It's generally in the SQL on Hadoop and big data space. And I've been involved in this area actually for over 10 years, previously as a chief architect at the Center for Hadoop, and also as a co-founder and chief architect of the company called Hadapt, which was SQL on Hadoop company.
And do you remember how you first got started in the area of data management?
Yeah, sure. So obviously I was interested in databases and SQL pretty early on in my career as a software engineer. But then I just leveraged databases as a way to store information needed by my applications. But what really got me started seriously thinking about database systems was when I joined Yale University and a grad school, and I actually started my PhD program. That was 10 years ago. And I was very impressed with sort of the great advancements in that field back then. So things like leveraging clusters of machines, leveraging columnar techniques, MapReduce, Hadoop, all of that really was picking up steam at that point, and that really was when I was really hooked into this area very seriously. Not just using the systems, but also building them, designing them. So I saw that as a great challenge and opportunity, and really wanted to focus that in my research. So actually, some of the results of my first research paper that I wrote with my team at Yale in the first year of my PhD program, we sort of developed a system called Hadoop DB, which was sort of a novel architecture that combined so the benefits of Hadoop and databases in one system. And we actually open sourced part of that system back then. And got really good feedback, lots of citations, conference talks. And then I followed sort of further into this area and into the topic of sort of split execution engine optimizations and achieve great performance results. And that work that I've done during the research, I sort of used as a sort of foundation to start a new company called Hadapt. I was sort of started together with some folks from Yale, Justin Borgman, who was back then Yale MBA student, and one of my advisors, Dana Buddy.
And so you briefly touched on the high level of what Presto is, but can you give a bit of a more detailed explanation about how Presto is used?
Yeah, sure. So Presto is open source distributed SQL engine. It sort of delivers fast analytical queries over various data sources, and they can actually range from gigabytes to petabytes. And the project itself was started at Facebook in 2012, and they made it open source a year later. And so their original goal was to offer much better performance than Hive, which was sort of at that point pretty much standard for running SQL on big data. So they wanted to do something that's truly interactive and highly concurrent, and Hive wasn't really offering that. And the other thing that they really wanted, something that they saw at Facebook internally, was that it's not only Hadoop, right? There are multiple different data sources. So they really wanted a SQL on anything engine, and separation of compute and storage, and something that makes Presto really uniquely positioned to deploy it basically anywhere, and whether that's on premises or virtual environments or in the cloud. And I think that's really pretty powerful architecture.
And some of the other tools that are existing in that similar space of SQL on anything are things like the Drill project and Impala. So I don't know if you can do a quick compare and contrast between the benefits that Presto provides versus the use cases that those other tools provide.
Yeah, sure. Actually, I think all of those tools started around the same time, 2012, 2013, and those all of them were kind of response to the current needs. What distinguishes Presto from Apache Drill and Impala is while they are similar on the sort of high-level architecture, seems kind of similar, right? You have a bunch of machines in a cluster, a bunch of worker nodes that together compute the query, and they often offers flexibility to reach out to other data sources, especially Drill. I think really has a bunch of connectors to other platforms. So what distinguishes Presto from them, I guess, is that it was actually built towards real needs, high concurrency scale. At Facebook, someone who's not a vendor like Mapar, who built Drill in the first place, or Cloudera, who built Impala, right? It was built by someone who's really strict production requirements, real use cases. And I think that focus made the Presto slightly different. It gained lots of more adoption from other big companies that are just dealing with scale and concurrency. And it wasn't really tied to any specific product on the market, wasn't pushed by any vendor, to some extent enjoyed sort of the benefits of sort of developing towards and being ready more ready for real production, high scale use cases, while not being pushed as a product to be sold to companies. And I think that helped a lot. So what you see as an effect of that, what you see is that unlike Presto, you can't really see lots of sort of spontaneous user sharing their great experiences with Drill or Impala at the conferences or on their blogs, right? But you see a lot of that for Presto, and to some extent, I think that speaks that Presto really is a great thing that delivered what promised and is really actually used extensively at the use cases that those other projects are not really seeing.
And so, as you mentioned, you built the Starburst Data company as a means of supporting Presto and providing a more enterprise-grade distribution of it. So what is it about the Presto product that was interesting enough and compelling enough to build a business around it?
Yeah, that's a great question. So during the last couple of years of my involvement in the project, and that's back at during that time, my times at Teradata, Presto has experienced sort of unprecedented growth in popularity, really, and user adoption at enterprises of sort of all shapes and sizes, from sort of fast-growing internet companies to sort of Fortune 500. And besides Facebook, some early adopters included Airbnb, Dropbox, Groupon, Netflix, among others. And then sort of the acceleration of the roadmap that we also contributed to, and successful sort of proof of concepts really led to production deployments at companies like Bloomberg, Comcast, Finra, LinkedIn, Lyft, as well as Slack, Twitter, Uber, and Yahoo Japan. So we served those customers, some of those customers. My team at Teradata was really both contributing and supporting those users. And given the number of adopters across many other industries, including telco, healthcare, retail, financial, we sort of were successful capturing some of that market really while being at Teradata. However, we thought there is even bigger opportunity to serve the broader market rather than just that sort of top 500 companies that Teradata focuses on. So basically, late last year, sort of part of my team really felt that we are ready to do it on our own, and that's basically how Starburst was born.
And What are some of the most challenging aspects of running and scaling Presto, or some of the most common problems that your clients are faced with that you're helping them with?
Presto, as I explained earlier, is really typically run on tens or hundreds of machines with lots of concurrency, potentially pretty complex queries, distributed data sources. So all of this, to us engineers really speaks about just technical challenge, right? So Presto and other big Presto users, especially in Silicon Valley, they have teams of engineers that basically take care of stability, performance, and scalability of their operations. And as your workload changes over time, you obviously need to monitor your system, manage resources, plan ahead, and plan for unexpected situations, right? So there is obviously complexity in all of this. And one way Starburst helps enterprise customers is by offering our subscription, right? So in addition to our free distribution, you can subscribe to our services that include 24/7 support, troubleshooting, tuning. And that really helps a bunch of companies. In addition, recently we also introduced a managed services offering called Presto Care. So with that, we can actually fully take care of your Presto environment, and you don't have to worry about it, right? And given our experience over 3 years in this project, we really are best positioned to get sort of customers most out of Presto.
And when people are using the SQL interface, given the fact that there are potentially so many different data sources with different ways of structuring the data, different APIs, are there particular edge cases or pitfalls that people should keep in mind as they're working on building those queries?
That obviously depends from data source to data source, right? So until very recently, there was no cost-based optimizer in Presto, and essentially any complex queries that are joining a bunch of tables were a challenge, right? One would need to be careful and avoid joining two large tables at the beginning because that would essentially impact all subsequent operations in that query and make like the overall experience not so great. In the recent release of our distribution, we actually included sort of our early work on cost-based optimizer that basically takes advantage of statistics about the data that you may have collected. So, for example, if you know the size of your tables and some information about your columns, such as number of distinct values, min-max values for each column in a table or partition. Given this information, the cost-based optimizer is pretty good in figuring out the join order and the type of the join distribution automatically. And there's actually a bunch of information about this topic on our website if you want to read more about this and see the benchmarks and some technical explanation. I encourage you to take a look at our blog posts there. But really, that obviously helps for some of those cases. I think we have still further work to make sure that you can expose statistics for all the connectors that are available in Presto, not just the most popular HDFS S3 connector. So in the meantime, if you are trying to join some less popular data sources, you need to be careful how you structure your queries, essentially. And some things to help you with that are basically classic explain, analyze commands that you can run. And Presto will respond with the query plan it's planning to run for a given query. And also in the case of the explain, analyze, it will actually run the query and collect a bunch of metrics, and you'll be able to realize where the most of the time goes, really, right? So for example, pretty often you realize that for example, you forgot to include a predicate on the partitioning key, and you're suddenly reading over a petabyte of data, right? And there's no way that query can be fast, right? Unless you have lots of machines computing that query and nothing else is using the system. or maybe you forgot one of the join keys, and for example, you have unnecessary explosion of intermediate data during your query plan. So basically, what I'm trying to say is based on the data source and your particular situation, I think there are tools to help you. There's also pretty good Presto UI that helps to get an idea what's going on in a Presto cluster and how given query is performing, and what's time CPU time used at every stage, and so on, how many bytes are moving between the nodes. So all this tooling will help you in cases when optimizer is not yet fully covering your case. But for the most popular data sources such as HDFS and S3, we can actually do a lot to help you with that.
And so the cost-based optimizer is definitely one very significant additional feature for Presto. I'm curious, what are some of the other tooling or enhancements that you have been working on at Starburst for Presto, and which of those get contributed back upstream to the mainline project?
Let me actually speak about the contribution made in the last 3 years. So they basically spanned the time when our team was back at Teradata, and now it's Starburst, because there's a continuum really here. So in the beginning, we actually worked a lot on the ease of installation and managing the cluster, and we built a tool called Presto Admin, and we contributed that back to the Presto project. And that basically allows you to sort of relatively easy install, configure, restart as needed. And before that, there wasn't really anything to help you with that. You would have to essentially develop your own sort of scripts or like Presto into your sort of overall cluster deployment mechanism. And sort of after overcoming that barrier, we focused on some of the enterprise requirements, such as integrations with security mechanisms. So, for example, Presto now fully supports Kerberos as well as LDAP, and those are obviously a must in any large enterprise organization, and increasingly also in those internet companies, believe it or not. And then we've sort of switched gears and started focusing more towards the core of Presto. So we implemented a bunch of enhancements to the ANSI SQL language compatibility, so such as correlated subqueries, decimal data type, and many more little SQL features that basically now allow us to claim really good coverage of ANSI SQL. And then we also contributed to building new connectors such as SQL Server, for example, and we also enhanced existing ones, Cassandra, based on requirements heard from our user base and community. And then a bunch of work on performance. So we mentioned cost-based optimizer, but we also worked on sort of improving various elements of the execution engine, so that your joins or aggregations will basically run as fast as possible, and that often means just moving fewer bytes across the network or within memory of Presto workers. And then so one really important feature that we implemented spill to disk, and spill to disk essentially allows queries to no longer be limited to execute in memory, which was for a long time a serious limitation in Presto, and one would need to basically have enough machines in a cluster to fit all the queries in memory while they're executing. Yeah, and in addition, obviously behind the scenes, we built various tools to help us develop Presto, and we have a testing framework called Tempto, as well as a benchmarking tool called Benchto. And both of those are also contributed back as a sort of a satellite project to Presto to help anyone who's serious about not only using Presto but also contributing back. And I would also stress that actually all of our contributions that we've made while at Teradata and now at Starburst, we are making those open source and contribute back to the core Presto. So the community as well as Facebook, Netflix, and others can also leverage that. And this is awesome. Because in exchange, we also get contributions back from those users to Presto. So, for example, quite recently, Uber contributed geospatial functions, and now Facebook is making them even faster. And we get that too. And plus, our functionality is now used at all those companies, and that basically contributes further to verifying it performs well, it scales well, and it's stable. So it's really great collaboration with the community here.
And so it sounds like the differentiating factor for your distribution is just that it has all of your contributions before they get merged back up into mainline. Is that accurate?
Yeah, I would say that is true. We obviously have some advanced work that we are maybe finishing this month, and it's already in our distro because we are confident in this and those features. So we tested them, and we can include that in our distribution, and then we are merging that back upstream. Sometimes it's a quick thing. Sometimes it takes a few months because it's a large controversial feature. So optimizer is one of those. It's a massive change in the whole in the entire Presto. So it needs more eyes from the community to look at that and really get approved and go through all the code review and testing and making sure there are no regressions that we do not think about and so on and so on. So that's one value of the distribution. The other is really because we release that distribution every 3 months or so, we have sort of time allocated to make it really well tested and stable because we are offering our support services for that distribution, right? So we really want to make sure it's actually stable for our customers, and that's unlike the releases in the community, which actually happen every 2 weeks or so sometimes. So you may be on the cutting edge, but sometimes you obviously experience some of the instability and bugs that just appear because of the fast-paced development in the open source.
And digging a bit deeper into the architecture, there are certain aspects of the way that Presto is designed that are core to the execution engine, and then there are pluggable components that allow you to add support for additional data sources or additional processing. So I don't know if you can just talk through that briefly.
I think as we mentioned upfront, like Presto was built as a purely compute engine, just running SQL. It's not tied to any specific storage engine, which the benefit of that is that you can query many different things, but it's also a trade-off, right? Because you are not tightly combined with the storage. You may not, for example, support things that a classic database would do. For example, right? Database would manage transactions, would manage referential integrity, and lots of different things that Presto, which is really sort of read only or append only system, is not really trying to solve at all. And won't be good for sort of any transactional workload, for example. It's purely analytical engine that sort of looks at your historical data. But because Presto was architected to distinguish the compute from storage, and because Facebook in the early days already saw that there are multiple different data sources, even at Facebook, so they architected this so that you can actually implement connectors for more than one data source. And Presto today already offers a bunch of those. So for example, in addition to sort of the file systems and object stores, you can query NoSQL engines, for example, Cassandra or Accumulo, as well as databases such as Postgres, MySQL, SQL Server, but also things like Kafka or Redis, right? So that sort of speaks to the expressiveness of that API. As long as you can make sort of the mapping between the data that you have and relational model and expose this data as a set of tables with rows and columns, Presto will be able to serve as a SQL engine on top of that. And actually, I'm aware of additional connectors being built by the community right now for things like Elasticsearch, Apache Kudu, or Apache Phoenix. And because the SPI allows you to do it yourself, there are companies building SQL layer for their own sort of proprietary data sources that may, for example, expose data via a REST API or Thrift API or things like that. So it's pretty powerful architecture. And then what helps is obviously on the front end, it speaks ANSI SQL, so you can plug in any BI tool or any SQL query tool, and whether that's sort of crafting your own SQL or using sort of custom application that leverages JDBC driver or or a Python driver and powers your own dashboard, for example, right? So it's really powerful that way.
And is that the typical way that the Presto engine gets used, is as a translation layer between multiple sources for being able to feed into another tool, whether it's a presentation layer or a report tool? Or is it also commonly used as just doing exploratory analytics using the SQL interface to do interactive queries?
Yeah, I think we see both actually, right? So just judging by volume and the number of people using it, I would say the Presto as a SQL engine over S3, like in Amazon Cloud, or SQL for your data stored in Hadoop, right? Those are the most common cases. But we actually see the growing need and popularity for running queries across multiple different data sources in one Presto installation. And some examples of that are when you have your archival historical data in your Hadoop, for example, in HDFS, but also you may have most recent sort of online data in a Cassandra system or actually in your Kafka topics, and you want to run a query that will sort of combine those two data sources and present you with what's the latest versus what was there in the past, right? So you see those use cases really growing as well. So I would say both are interesting. What distinguishes Presto from some of other engines that can also do that, for example, Spark, is that you can actually drive a lot of queries concurrently, and they will be really fast, like low latency, and that makes sort of Presto really popular for those both ad hoc analytics as well as sort of reporting and driving dashboards and things like that.
And in terms of things like the security model and the schema introspection, are those things that are the responsibility of the source data stores, where you maybe have to create a Postgres user that has specific permissions to give in tables, or is it something that can be enforced at the Presto layer for ensuring that certain people have access to certain aspects of the schemas?
Okay, good question. So it's really both, right? There's intersection of those. I would say that the Presto itself will not be able to protect your data at rest, right? That's the responsibility of your data source. Say in your case, Postgres, right? Database, you need to have the right permissions for the certain users for given tables, and that needs to be guaranteed. And then when Presto accessing a table that happens to be stored in your Postgres instance, then will basically leverage a configured user and read from that table and brings relevant rows and columns from Postgres into Presto for further analysis and maybe joining with other data sources or just aggregating and returning to their user. And the connectors actually vary between themselves in how much of the security integration between Presto and the data source is available. So in a case of Postgres connector, there's basically a service user that you configure for that connector, and basically Presto will be using that user to fetch the data of Postgres. So essentially, you need to make sure that specific user that will be actually authenticated via GDBC can leverage access all the tables that you want to expose to Presto users. In case of other connectors, for example, the Hive HDFS connector, Presto can do much more, and it impersonates a user that's accessing Presto, right? So you may have multiple different users accessing Presto. Presto will impersonate them when talking to your data source. And for example, will be impersonating HDFS user as when reading the data of HDFS, right? And that basically ensures that if that specific user that you may authorize and authenticate via Kerberos when talking to Presto is passed through for all those layers, and the same user we use to fetch data off HDFS. And if that user has no right to see given information, it will you'll see an error, or you will not be even able to see the table at all, right? So I think that integration chain, it's available in the Presto connector API. You can leverage it, and various connectors implemented to various extent. And I think there's probably more that can be done to make it even more smooth and transparent.
And in particular for sources such as a collection of files in S3 or various other flat files, are there ways for Presto to be able to introspect those schemas? I'm assuming that it relies, for instance, on the embedded schemas in Avro or Parquet files, but is it possible to define a schema for things like JSON flat files as well?
Right. So in Presto actually assumes that you have to define a schema in the case of object store, that would be the Hive meta store. So you have to define a schema saying, okay, well, the data in this bucket, right, in S3 bucket or HDFS folder is following this schema, right? And it's a simple operation because you're not actually reading the data, you're just declaring the schema for that data, simple DDL command. And you can access the data that's already there, right? So just creating like an external table, essentially, right? And in that mapping, you will say, okay, I interpret the first column as an integer, and the second column as a string, and data type, and whatever, right? And that when reading, then Presto will use that schema, will expect this kind of data, and will read your Parquet file or JSON file, and basically will sort of map that information read of disk or of your storage to the schema that it expects. If it happens that you have a file that completely there's no way we can interpret that file according to the schema that you provided, then we'll say, well, there's probably corrupted data there, right? But so Presto itself will not try to discover the schema that you may have in your Parquet. You need to sort of provide it in a create table statement, but Presto will do the validation of that data versus the schema that you offered.
And in terms of scale, it's obviously able to handle very large sets of data and very largely distributed node counts, but does it also work equally well in a small scale deployment where you're only using it, for instance, on a single server on a data set that's maybe only a few gigabytes in size?
Yeah, I would say yes. That's obviously not a common deployment, but I do have a Docker with Presto even on my laptop for demo purposes, or if I want to check something very quickly, I can do it on my laptop. You can deploy it on one server, and it will work just fine. The good thing about Presto is that because of its architecture, if your dataset grows or the number of users, concurrent queries, or complexity of the queries grow over time, you basically can just add node, right? Add more nodes to the cluster, right? And you can start with one, and then you have 10 and 20 and 100. And I'm hearing that Facebook is running clusters that are approaching 1,000 nodes in a single Presto installation even. So this thing will scale to beyond what you probably need or would ever need, right? And I think that it brings sort of peace of mind to many customers, knowing that there are users running this on hundreds of machines at really high scale and high concurrency.
And are there limitations in terms of the ways in which you can scale as far as the network architecture? So, for instance, does it support geographically distributed clusters where you have subsets of the machines within multiple different data centers and being able to aggregate and merge the data across those nodes for a single query?
Mm-hmm. So that is not a common use case for Presto. In all the deployments I've seen, the machines are always sort of within a single data center, and for really high performance cases, you actually want a pretty fast network between the Presto workers, right? and also between the Presto cluster and your data source, right? Because if you happen to be limited by, say, 1 gig network somewhere along the line, then that may mean you cannot read data fast enough, or you cannot exchange data between Presto workers fast enough, and your queries will suffer, right? So Presto is really, because it doesn't keep the data, it's a compute engine. During the compute, you expect interactive speeds. You really want to deploy Presto on an environment when you have at least 10G network, and ideally the nodes will be close to each other so they can exchange the data really fast, because most of the operations in a SQL engine is fully parallelizable, and it's actually very simple to parallelize them, and Presto leverages that a lot. And if I cannot exchange data between the nodes fast enough, that interactive experience will suffer. So it's not really a common case for Presto to be deployed across different data centers, or like as a single installation, right? You may have multiple separate installations, and maybe there's a Presto installation that kind of is trying to leverage those local installations somehow. I can imagine doing such architecture like this. I don't think it's a common case right now.
And what do you view as being the long-term future of Presto? And are there any particular enhancements or new features that you or others in the community have planned?
Performance is really a never-ending topic, right? So there's many things we would like to enhance in our optimizer to be even smarter for more and more complex queries. There's constant fight to increase stability and scalability and concurrency. So a ton of work goes into that. There's a number of security integrations that we would like to do as well, especially for our enterprise customers. I think there's a number of things we can do even better. Just, if you just imagine, like, each data source typically comes with their own security model, and sort of making sure Presto can encompass all of those and present a sort of coherent view is definitely still an open question, how to do it really well. There's definitely things that we can invest in terms of integrating more advanced analytical functions into Presto. I mentioned the geospatial is becoming a really popular use case, but there are more things like this that we can invest in. So more connectors to more data sources, right? There are still data sources that Presto cannot connect to. I think we can improve that. And then for us at Starburst, I think investing even further into making Presto really easy to use, and also easy to inspect, like for a DBA, for example, just like get a holistic view of how my cluster is doing, how my users are doing, who's running the heaviest queries, and how to help optimize the system towards the use cases that I see. I think this is something we would like to continue to work on as well.
And one other thing that I was discussing with someone recently is I'm curious about the support for nested data within a given column, for instance, like being able to query into arbitrary, for instance, JSON structure or nested schema for being able to pull out some of that data.
Presto is actually handling that case pretty well. It obviously works with Parquet and org files and JSON, so you can actually have complex column types. And I think at this point we have pretty good support for arrays, for maps, and for rows, which is essentially struct, which could be arbitrarily nested. So all of those are very well supported in Presto. I do recall there are some optimizations that community is still working on to make sort of when you actually have, if you just want one little bit of information of your whole nested data structure, the naive way to do it would be just to read this entire nested data structure, which might be actually pretty large and pretty complex, and then after reading that off your storage, just in memory extract that little thing that user needs. I think this obviously can be improved by pushing down to the scan level that nested predicate that someone included in a query and pushing that to storage. And I think there's some community work to address that for Parquet, I believe, at this point. So there are some things we can optimize even further, but nested fields are definitely fully supported right now in Presto.
And so, for anybody who wants to follow the work that you're up to and the work you're doing at Starburst, I'll have you add your preferred contact information to the show notes. And as one final question, from your perspective, what do you see as being the biggest gap in the tooling or technology that's available for data management today?
Okay, I think it's an awesome question. Data sources and data management systems are obviously evolving, and just watching that space very closely in the last decade, just brought so much to the table, and things that we thought would be absolutely the future 10 years ago. Well, some of that is actually no longer the future; it's the past, right? And so an example, right, is the fault tolerance that was really important 10 years ago. I think, it found its use cases, but is not taking over the world. Actually, there are still systems such as Presto, actually, that make a trade-off, and they trade fault tolerance for performance and prefer performance rather than fault tolerance. And it wasn't a common belief even 10 years ago. And in the future, I think what we'll see is further sort of specialization of those data stores and data management systems. They will become even more sophisticated and tailored to specific use cases rather than one that will fit all use cases, even though everyone would prefer just one SQL engine because they have so unique capabilities and they are good in other things. I don't think we'll see one to rule them all. So more fun for us.
Well, thank you very much for taking the time today to talk to me about the work you're doing with Presto and Starburst Data. And thank you.
Thanks so much. It was a pleasure to join you here.
Sure. And I hope you enjoy the rest of your day.
Yeah, you too. Thanks a lot.